Hey guys, welcome back. I hope you guys enjoyed yesterday and trying to really brainstorm what the term energy means. So when we went through it, there were a lot of pictures that went through. There was a lot of terminology that you guys came up with. And now what I want to do is really give you a scientific definition on what energy is. But before I give you the actual definition, I just want to talk to you a little bit about energy. Energy is everywhere, and it's everything. And it comes in a lot of different forms, but it all has the same purpose. And here's the definition for you. The purpose of energy is the ability to do work. Now I know that may seem confusing. You're like, well, work, that's not what we do, because we're still kids. No, not that type of work. See, in science, we use some of the same terms, but for different definitions. So for us right now, for the term work, work is the act of displacement of something by applying force. Simply, to apply force over a distance on an object. And what is force? As much as I would love to tell you it is the Star Wars moving objects, it's not. I know, I'm disappointed too. Force is a push or pull to change the motion of an object. So it's a simple push or pull to change that distance, change the motion, that distance of that object. Some fun examples of using energy is, say, throwing a baseball. When you throw a baseball, you have to really arc yourself, throw your hips back, and forcefully throw that ball across the field. But that's just one type of energy. I'm also talking about all sorts of energy. The way when you turn on the light when it's dark out and you see the light bulb turn on, that's a type of energy. When you're cooking up some yummy toast or burgers, that's using heat energy. And we'll talk about that coming up as well. And you may be thinking to yourself, how does everything contain energy? Because you may be looking around your computer now and being like, well, wait a minute. I'm sitting down. I'm not moving anything. I'm not pushing anything. I'm just sitting here. How do I contain energy? What about the stuff on my desk, my pencil, my notebook? Those contain energy? What about the stuff behind me? Maybe you're in your living room, such as my couch, or a box, or even a log. All those things contain energy. It just depends on what type of energy we're talking about. For instance, a log obviously is wood. And wood is made up of chemical energy. The chemicals involved to make wood are carbon, hydrogen, and oxygen. All form ligaments to make wood. And what happens when you heat up that wood? That's right, it becomes fire. Alright? The reason why it becomes fire is because the heat that's being added to the wood breaks those chemical bonds. And it releases as fire. So hence why we use logs to make a campfire or a bonfire. Wood also has nuclear energy in it. And what I mean by that is I don't want you guys to go straight ahead and think like, oh my goodness, Mr. Paris said nuclear war. Oh man, everything's gonna go like kapooey. That's not what I mean at all. What I mean mainly is when I say wood has nuclear energy, it's because the atoms involved have a nucleus. And when you have a nucleus, you have nuclear energy. Now obviously it's not a lot, because when we put wood on the fire, we don't go kabooey. We just sit and enjoy a nice little campfire. That's all. But just so you know that wood also contains all these different levels and forms of energy. And you may be thinking to yourself again, well wait, what happens when the wood is done? Like when it's all burned up? Then the energy is gone. Wrong. was doing is done. But the energy that it contained is not. Hence why we have, like, say, ash. Hence why you see the smoke kind of come up. Is because the energy is not done. There's a fun law out there, and you guys please write this down. It is called the law of conservation of energy. And it states that energy cannot be created nor destroyed. Now, I know what you might be thinking, and I apologize for just using that reference over and over, but I know what you might be thinking as far as like, but we just created fire, right? So energy helped create that fire. And yes, you're right, we did kind of create the fire, but the energy from the wood to create that fire was not created. It was already there. And before it was there in the wood, it was used for something else. Because energy can't be destroyed or created because of that law of conservation. So the energy is transformed into different forms when you see it. One day it may be used in the wood. The next it will be used in the for, let's say, in the air. So energy itself can no longer be destroyed, nor can it be created. And if you think about it, all the energy that you use on a daily basis throughout your entire day has been recycled since, well, forever. Some form of energy, though, and I can think of some examples, can only be used once. And this is where you get the terms, say, renewal and non-renewal natural resources. And that's why you'll hear people kind of arguing, we need to save the planet by using solar power, wind power, water power. Those are forms of renewable energy sources because the sun keeps giving us its beautiful sunlight. And when we use that sunlight for whatever energy or to power up whatever item that we're using, it changes then back into, it keeps going into, it keeps its change as sunlight. Same thing with water, same thing with the wind. But there are some resources out there that don't do it. Once you use it, it's gone for good. And those are some examples of, say, gas, such for your car, as well as coal, such as for trains. So once you use this form of energy, that is gone. But again, the energy, because of the law of conservation, it is not destroyed. It is just simply moved from one form to another. And it can't go back into being that fossil fuel, that gas, that coal. So that's, again, why we have renewable resources. Like I had stated previously as well, there are many types of energy, and they're always changing. From mechanical to thermal, and from sound to electric energy. And there's many, many more. The two main types of energy I want to focus on right now, and to give you your first step into learning about energy, are dealing with mechanical energy. Mechanical energy is the energy an object has based on its position or motion. And I'll explain a little more clearly what I mean in a couple seconds. But essentially what mechanical energy also contains are two different types of energy forms. One is called kinetic energy, the other is called potential energy. Kinetic energy is energy that's always in motion. It's always moving. So no matter if you're riding your bike down the hill, if you're running up the stairs, if you are throwing a football across the field, if you're driving a car from here into town, you're always then using kinetic energy because you're always moving. Potential energy is the exact opposite. You're not moving. It is stored energy. It has the use to be used as kinetic energy. But for right now, you're storing it up, saving it for a rainy day. And so what this is or what this is used for is to kind of tell the difference between when one type of energy is used rather than the other. So if you see a pendulum, let's say for instance, or let's say a swing actually. Swing. So if you come outside with me, I'll show you exactly what I mean as far as using kinetic versus potential energy. Come on. So thank you guys for joining me today. And right now I'm going to show you guys on a swing how to use potential and kinetic energy. So when I'm sitting down and not moving at all, I'm using potential energy. I'm keeping all that energy stored up and not moving just yet. But the moment I start moving, that's me using my kinetic energy, but also potential energy. And here's why, is that when I'm back and I start going down, that's using that kinetic energy. So going back and down, that's kinetic. As soon as I go up, I'm still using kinetic energy. But the moment I reach the top, now I'm using the stored energy. Now I'm using potential energy. And when I come back down, that transfers back into kinetic energy. So let me show you. So kinetic, potential, potential, kinetic, potential, kinetic, potential, kinetic, potential, kinetic, potential, kinetic. Got it, guys? It was great getting to do this with you. I hope you guys enjoyed it, and I'll check you later.